So one of the most important things about modeling climate change is, of course, climate projections, and of course understanding past climate changes in terms of a contribution from human activities, as we saw with the detection and attribution, which gives us confidence about the models, and also in terms of using them in policies and so on to protect ourselves from the most serious damages, and to set targets, global warming targets, which then translate to emission targets that have to be met, and so on and so forth. But there is a lot of sausage making that goes on behind the scenarios. So here are the older ones, the so-called special report on emission scenarios, which were CMIP 3 released in 2007, and CMIP 5 was released in 2014, and they were then called representative concentration pathways. So global temperature change and uncertainty, global temperature change, mean and one standard deviation as shading. Relative to 1986 to 2005, you can use different base periods, it doesn't matter in terms of the story. For the SRES scenarios run by CMIP 3 and the RCP scenarios run by CMIP 5. So there are lots of changes in the Coupled Model Intercomparison Project 3 and Coupled Model Intercomparison Project 5 in terms of the basic models, the resolutions, the details of the models, the number of models from different centers in the world, and of course with them the parameterizations, the formulations, the microphysics, the convective aspects of the atmospheric model, and so on and so forth. And there are always lots of papers written comparing CMIP 3 to CMIP 5, trying to see how monsoon improved, how El Nino may have gotten better, how 20th century simulations have changed, how climate sensitivity is different, and so on and so forth. So a number of models are given here in brackets. So historical simulations were done by 24 models. Different SRES scenarios, B1, A1, B, A2 were done by different models for various reasons, computational resources being the most important one. Not all models do all the scenarios. And here for CMIP 5 model, you can immediately see the number of models has jumped. Historical simulations were done by 42 models, and RCPs here, representative concentration pathways, are similar to SRES in terms of looking at where the emissions will go in the future based on technologies for energy, transportation, how population would grow, and what kind of policies would be adopted, how bioenergy and carbon capture and sequestration would play in, and how renewable energies would contribute, how coal would be phased out, and so on and so forth. So the numbers 2.6, 4.5, 6, and 8.5 were determined by various combinations of full coupled models, iterating with integrated assessment models, which we haven't defined, but those are basically models which are representing climate in a simple way, but they focus more on socioeconomic sectors like energy, transportation, food, and so on, so that you can see how emissions will change based on those options, and then go back to the climate models and see how those emissions would affect the details of the climate evolution. So it's a complicated process, but the numbers here 2.6 to 8.5 correspond to the radiative forcing at the top of the atmosphere by 2100. So the most benign scenario here of RCP 2.6 would keep us almost below 2 degrees C target if we didn't exceed those pathways, and 4.5 to 8.5 is basically like a business as usual, where we don't do anything, we don't have any policies to constrain future evolution of emissions. And unfortunately, if you look at these historic emissions here in years, so this is global surface warming, but you can also look at it in terms of CO2 emissions. It turns out that despite the negotiations of over 25 years, we haven't really budged on the total emissions, which is unfortunate. So that only puts more pressure on how quickly you have to turn down the emissions. So those are the emissions, and the next CMIP 6 has what are called SSPs, as I will show in a minute. But you can see that the range of here, this is the warmest one, which almost corresponds to the business as usual RCP 8.5 here. But you can see that this is showing a warming of 3.5 degrees C maximum by 2100, whereas this is showing about 4.2 degrees centigrade by 2100 with respect to the baseline. The number of moles, so the box plots here mean one standard deviation and minimum to maximum range for 2080 to 2099 for CMIP 5 and for MAGIC climate model calibrated to 19 CMIP 3 models, both running the RCP scenario. So they did some comparisons, but nonetheless you can see the range of models hasn't changed that much if you compare CMIP 3 to CMIP 5. Nonetheless, you can see how things look in terms of going from the historical warming to future scenarios, just comparing the same periods 2007 onwards for better ease of comparison. Okay, so the details of creating these scenarios and creating protocols that every modeling group must follow, and all the evaluations they have to go through and so on, are split into these kind of intercomparisons. This is the cloud forcing MIP, so dynamic variability MIP exists as well. Regional phenomenon, ocean model intercomparisons. CORDEX is the coordinated regional downscaling experiments. Scenario MIPs are done, decadal predictions are done, geoengineering MIPs, land use MIPs, carbon cycle MIPs, and chemistry and aerosol MIPs, the radiative forcing MIPs, and paleo MIPs are done. So they all focus, so these are the CMIP 6 experiment, looking for systematic biases, variability, predictability, and future scenarios, and response to forcing. And these are the various things looked at: clouds in circulation, regional phenomenon, ocean, land and ice impact scenarios, and so on. So very, very detailed, lots of the scientists involved, lots of work involved, lots of protocols to follow so that comparisons can be done fairly among all the models, and so on. Okay, so IPCC representative concentration pathways shown here in terms of CO2 equivalent in parts per million by volume from the time they were designed back in 2010 or so to 2100. As we said, RCP 2.6 is the most benign one, and you can see that it needs to start reducing emissions and atmospheric accumulations by 2040 or so to be able to maintain the radiative forcing to 2.6 watts per meter squared at the top of the atmosphere. 4.5 is here, RCP 6. For various details, it remains below RCP 4.5 till about 2060, and then takes off and reaches 6 watts per meter squared, and RCP 8.5 just zooms along with business as usual there. Just for completion, CMIP 6 combined RCPs and created also what are called shared socioeconomic pathways, which focused on mitigation and adaptation and sustainability metrics. So it had a phase space where mitigation challenge was high, or mitigation challenge was low, and adaptation challenges were low or high, and the various combinations. So you can see here emissions associated with each of them over time. For rapid growth scenario, which amounts to business as usual. Regional rivalry, you can look up the details if you want, but you know what it means. Inequality, so you don't care how the implementations are done for meeting the global warming targets. So you can see that the reduction in CO2 emissions are accomplished without worrying about protecting the poor, who may be suffering more for the lifestyles of the rich, for example. And sustainability goal is here, and there are some middle of the road scenarios here as well. And it gives you range of emissions, that net emissions that you would end up with in each case, and also shown are the range of warmings, less than 6 degrees here, with the range going from somewhere in the 4 to 6 degrees, less than 5 degrees, and down to less than 2 degrees. 1.5 doesn't even appear here. So that's what we are dealing with in terms of scenarios. Of course, you have to combine the RCPs with them. So baselines still include RCP 6 down to 2.6, so the 8.5 is gone here in terms of business as usual. So that has to be kept in mind. So they have various combinations of SSP1 2.6, SSP1 4.5, and so on and so forth, which combine RCPs with these SSPs. And those are how the assessment report 6 reports projections. Okay. Just to quickly make another point, here are comparisons of RCP 8.5 for 2016 to 2035 with SRES A2, comparing the different seasons of temperature and precipitation. So DJF, JJA, and different period 2081. So earlier decades and later decades, you can see different seasons. Obviously later decades have much more warming, and they look almost similar to the SRES scenarios. Even though number of models are more, the scenario details are different, and so on. And the stipple regions are where the models agree with each other, I think. And the story is very different when you look at precipitation projections, because precipitation is a notoriously difficult thing to do with the models. There are many details which we can discuss in another podcast. But again, looking at earlier decades and later decades, impacts are higher in the later decades of the RCP 8.5 scenario and SRES A2 scenario. But again, number of regions where the models don't agree are much more here than in the temperature projections. So models don't even agree with each other, which gives you pause in terms of how reliable the precipitation projections are into the future. And that also changes from the near decades to the outer decades, longer term decades, and the differences are larger here in the precipitations projections than in the temperature projections, because of the changes in the details of the representation, the resolutions, dynamic vegetations, and so on and so forth. So the key question then is, in the earlier decades, often it turns out that model uncertainties themselves dominate, whereas in the outer decades the scenarios begin to contribute more to the differences between scenarios and between models, and so on. So we have to keep that in mind. We'll come back and look at some more results from the climate projections, just to make additional points about climate models in the context of climate projections. Okay, so obviously it's a very brief introduction, and we are not going into the details of the models, and there are thousands of papers on the details of the models and how they do globally and regionally and at different time scales, and so on, which you can follow up if that is of interest to you, or that is your main study area, and so on. Okay.